Welcome everybody. My name is Rachel. Thank you all for being here. To start, we're just going to see where we are in the audience. How many people before they came here even knew Microsoft had a Postgres service? Yes, some, okay. How many people know what the other two open source databases are that Microsoft has? Anybody? Sorry? Mongo, so Cosmos has a MongoDB API, and there's also MySQL and MariaDB. So if you're interested in any of those other open source databases, you can check those out as well. So I'm going to give a quick overview of what we'll be doing in this session. First, we're going to talk about microservices and two common myths around microservices. We're going to be busting those two myths. And then for the latter half, we'll talk about 5 key considerations if you're deploying a microservice with PostgreSQL. So let's get started with myth busting. So myth number 1 is that microservices are for everyone. And yeah, microservices are this shiny new thing. Everyone thinks it's awesome. You should get a microservice. You should get a microservice. Actually, that's not true. Microservices are not for everyone. I really am of the belief that you start out by thinking, what are you building? Like, what are you actually building? What are your goals? And then deciding if microservices make sense for you. So I'm not here to advocate that you definitely have to have a microservice. It's more about, does it fit what you're looking for? OK. Second thing, microservices equal containers. And they often get spoken about in the same breath. Like actually, for this session, you'll see in the description that we talk about microservices, and then we talk about containers. But they're actually not equivalent. So microservices and containers don't have to go together. You can have containers without microservices, and you can have microservices that run without containers. The reason they're often mentioned together is that they have very similar characteristics. So a microservice is a small, loosely coupled sets of code. And containers are small, loosely coupled sets of compute resources. So you can see how they end up working together a lot. So in this session, we'll be talking about microservices and containers together, but it's up to you. They don't actually have to go together. OK. So let's talk about Postgres, which is where our focus is going to be. And as I mentioned, I'm going to talk about 5 key things to think about if you're deploying a microservice using Postgres. Number 1, consider statefulness. So if you're using a container service like Azure Container Service or Azure Kubernetes, you're usually operating in a stateless environment. Like most of what is going on there is stateless. But data is a very different kind of beast. Like nobody wants their data just vanishing. And so data has state, and you care about state. And so you have to be very careful when you're thinking about a database or a data service within a serverless or a stateless system like Azure Kubernetes. Some people choose to run Postgres within Kubernetes, and Kubernetes has this thing called stateful sets that help you to do that. I would actually recommend thinking about running Postgres outside of that. Again, because it's data and data is stateful, put your application code inside of Kubernetes, because application code you can spin up and spin down, scale out the pods as necessary. But for data, I would really recommend thinking about a separate system. Now, let's say you have your Azure Kubernetes service and you have your Postgres. You really don't want to spend too much time thinking about this separately. And that's where a managed service like Azure Database for PostgreSQL comes in. So Azure Database for PostgreSQL will take care of your backups for you. We run regular automated backups so that you can restore to any point in time in the last 35 days. We'll take care of the high availability for you. We'll do the patches for you. We have query performance insights, performance recommendations. There's a lot you're getting so that you don't have to be thinking about these two disparate services, but you're caring about the fact that your data is stateful. So this is my code slide. Because if you want to get started with Azure Database for Postgres, it's literally these 3 words. You go to a command line and you type AZ Postgres up. That's it. You're going to get an Azure Database for PostgreSQL server that you can immediately start with. And if you've used Postgres before, you just connect to Postgres, like host name, username, all that. It's just AZ Postgres up. So if you leave here, head to the Azure command line and do AZ Postgres up. Or check out our documentation if you need more instructions on that. OK. Number 2, choose connection pooling. So we're talking about microservices, and which means we're talking about lots of little things that may be trying to access your database. Now, if you don't know, Postgres, it's actually super costly to create a new connection because every connection is a forked process. So first of all, every time you create a connection, it is just sitting on a piece of memory. Like, even if the connection is idle, it's holding up memory in your system that you would rather have running your queries or taking care of your cache. And managing a set of connections is also super costly for Postgres. So a best practice, if you're running any Postgres service really, is to have connection pooling. Now, if you're using something like Rails or Java, they often have connection poolers that come outside of the box. But I would really recommend going for a Postgres-aware connection pooler. And PG Bouncer is a good option. Now, why that's better? Because Rails or Java or any other of those systems is trying to be very general about what you're going to connect to, they aren't as efficient when it comes to Postgres. But if you use a Postgres-aware connection pooler, you can do things like transaction pooling, meaning your app is only going to take a connection when it needs to run a transaction. So that makes it really efficient. You don't have as many connections just sitting there consuming memory. So PG Bouncer is a good option. In Azure Kubernetes Service, we actually have a sidecar available for PG Bouncer that you can just deploy alongside your application. Okay. So let's say you're putting PG Bouncer in. You would define the host name, whatever your server name is, whether it's changing, whatever that looks like. You define the pool mode. Like I mentioned, transaction is a really good way to go for Postgres. You say what your max number of client connections is going to be, and then you include it in your Kubernetes service. Number 3, leveraging your schemas. So think about it. If you're deploying microservices, the key thing is that you want them to be very loosely coupled. If they start getting dependent on each other and interlayered, you lose the benefit of a microservice. You end up just building a monolith with lots of different parts. So you want your services to be loosely coupled. So what does that look like when it comes to data? Well, each service should own a certain set of data. And if other services want to interact with that data, they should communicate via the API. They shouldn't be trying to directly access the database. So you could decide to do that by doing each one a separate server. That's costly. If that works for you, great. Or you could come to a lower level. Think about doing it at the database or at the schema level. But then being very rigorous about your access controls, your grants, so that only the service that's supposed to control that data is accessing it. Okay. Number 4 is publishing events. So we talked about how each service controls a certain set of data. So how do you make other services aware that, oh, maybe the account limit has changed here. Maybe the credit limit has changed here. How do you make other services that need to know aware of that? Well, event publishing is a really common architecture model that gets used in microservices. And Postgres actually has a native event publishing mechanism. If you haven't heard of it, it's called Listen Notify. And you can leverage that to publish data events. So I'm going to show a little bit of what that looks like. So you set up a channel in Postgres that's like listen account channel. And that's where I've named what the channel is. So whatever process I have is listening on that channel. And then in the second line, I'm giving an example. So you can simply say notify account channel and send in the payload. And then it's notifying. So in this example, because I'm running in the same process, I get the notification that says for this channel, I receive a payload, that's the payload, and this is where I received it from. Now, this notify mechanism, this is the simple format. If you're doing this in your code, you're going to get more advanced, and you want to use something called PG_notify. That's the process you want to be using, because you can get more rigorous about what you put in there. So you see at the bottom, I'm using a JSON build object. That means I can get really advanced about the kind of things I send into my payload. I can send the exact data that was updated, or I can build different JSON things depending on who I have listening on my channel. So this is a pretty good native mechanism that you can leverage for event publishing. Finally, performance. We all care about performance and how you're going to scale for that. So in Azure Database for PostgreSQL, you can scale up your compute, your memory, your IOPS, your storage with a command. You just say, I need more of that, and we'll give it to you. So you can scale vertically up that way, but then there's also scaling out horizontally, and that's where replication comes in. So Postgres has pretty good replication mechanisms, and we leverage that by providing you with read replicas. So a read replica is another Azure Database for PostgreSQL server that's following your primary and replicating the data over to it. So if you think about what we talked about in terms of microservices, defining an API, if your APIs are very well laid out, you can see, okay, these are my read APIs, or these are my services that are primarily doing reads, like analysis services, reporting services, that's what they care about. You can offload that onto your read replicas and take away that from your primary, and so you're scaling out your throughput in that way. So that brings me to the end of this session. If you want to learn more about scale in general on Postgres and getting even more distributed, I really recommend checking out Hyperscale. So Citus Data is a distributed Postgres service, and we recently acquired them and are bringing Hyperscale on Azure with Citus. So if you're interested in distributed Postgres scaling, if you have analytic throughput, that's the session to check out. There'll be a 1-hour session that would deep dive on that some more. If you care about more open source databases, there are sessions on MySQL, one for WordPress on MySQL, and the other for query performance on MySQL. Thank you, guys.